Hello, welcome to the Statistics Lab. In this video, we are going to conduct two-tail G-test for single proportion. Here, first we understand the question, then we talk about the procedure, and finally we solve the question step by step. So the question says, a hospital conducted a study to determine the proportion of newborns who are boys. In a random sample of 883 newborns, 433 were boys. A national survey claims that 51% of newborns are boys. Using a 5% significance level, test whether there is enough evidence to conclude that the proportion of boys in the hospital differs from 51%. So, what is the story going on here? The government agency conducted a survey in the whole country and arrived at the result that in the last year in the country, the 51% of newborns are boys. Now, one man wanted to verify this claim. So he went to a particular hospital in a particular state. He asked the hospital to provide the data for the last year. Then the hospital said that in the last year there were total 883 newborns, out of them 433 were boys. Now the person collected this data from the hospital and came to you. You are a statistician, so he wanted you to verify the result, right? So here we conduct a two-tail G test for single proportion. What are the steps in the solution? So the step one is collection of the given data. Whatever the data is given in the question, we have to collect them and write them down so that we can understand what kind of data we are provided and what kind of test we need to do. Then step two, we set up the hypothesis. In step three, we calculate the test statistics. After calculating the test statistics, we have two methods. One is critical value method and second is p-value method. So we can draw a conclusion based on both of the methods. So whatever method you are asked in your question, you can use that method. But here in this video, we will discuss both the methods. And we will see that using both the methods, we will arrive at same conclusion, right? Okay. So step one, the sample size n is 883 and the number of boys is 443, 433. So number of boys is denoted by small x and the sample size is denoted by n. The sample proportion, small p, is x by n. When we substitute these values, we get sample proportion as 0.49. So this is our sample proportion. Now, what the question is saying? The question is saying that the national survey claims that 51% of newborns are boys. So we can consider that in the whole country, the population proportion is denoted by capital P, that is 0.51. And again, in the question, we are provided that the significance level is 5%. The significance level is denoted by alpha. Now, second step is setting up hypothesis. The claim is that 51% of newborns are boys. So the null hypothesis says that the population proportion is 0.51. When we write it in notation, we can write H naught capital P equals to 0.51. What is the alternative hypothesis? Alternative hypothesis, we need to check that the population proportion differs from 0.51 or not. So in notation, we can write H1 capital P naught equals to 0.51. So, what is the tail of the test? The tail of the test is always determined by the alternative hypothesis H1. Whenever the alternative hypothesis is having not equals to sign, this not equals to sign, then we say that this is a two-tailed test. Now in step 3, we go and calculate the test statistics. This is the formula of test statistics. Small p minus capital P divided by square root capital P into 1 minus p divided by n. And this test statistics G follows normal distribution with parameter 0 and 1. We substitute the values of small p and capital P in the formula of test statistic G, and when we simplify it, we get G equals to minus 1.19. So this is our calculated test statistics, minus 1.19. Now, first we find the conclusion based on critical value method. So in step 4, we find the critical values. This is a two-tailed G test. Hence, there will be two critical values. For a two-tailed test, there are two critical values. So in G test, for significance level 5%, the critical values are minus 1.96 and 1.96. Now here one can ask that how can we find the critical values? Well, for that I'll create a separate video. I will provide the link in the description box. You can check out the video from there. For now, you can remember that for a two-tailed G test, for significance level 5%, the critical values are always plus minus 1.96. And this is very common. Every statistic students remember them. The critical values for G test for significance level 5%, the critical values are plus minus 1.96. Now in step 5, we have to draw the conclusion based on the critical values. So what was our test statistics? Minus 1.19. Now the acceptance region. The acceptance region is minus 1.96 to 1.96. So the interval between the critical values is called the acceptance region, right? So if our test statistics, what is the decision rule? The decision rule is written here. What the decision rule says, if the value of the test statistics is inside this interval minus 1.96 to 1.96, then accept H naught because this is the acceptance region. If the test statistic is inside this interval, then accept H naught. If the test statistics outside of this interval, then we have to reject the H naught because whatever value is outside of this interval is the rejection region. Now, what is our conclusion? We can see that the test statistics value minus 1.19 is inside this interval, right? Hence, this is in the acceptance region, so we have to accept H naught. So, based on the critical value method, we have drawn the conclusion that the null hypothesis is accepted. Now, if you are asked to draw your conclusion based on the p-value, you can use the p-value method also. So now we will proceed to see how the p-value method works. So in step 6, we calculate the p-value. In a two-tailed test, the best ever blood pull-up formula to calculate the p-value is given by this. This formula might look little bit hard to you, but believe me, this is the best ever formula. Why? Because sometimes we get this test statistics small g as positive, and sometimes we get is as negative. So students get confused how to find the p-values. But no matter you are getting positive value or negative value, you just need to put the test statistics value here and you find the p-value in a two-tailed test. This formula is applicable for two-tailed test, right? So the formula says you have to multiply by 2 and you have to subtract from 1 and you have to subtract this probability capital G less than absolute value of test statistics. So on the place of small g, you put this calculated value of test statistics minus 1.19. Then in the next step, you take this absolute value. Now, first we have to calculate this probability from the G table, right? Then we will put this probability here. Then we subtract the probability from minus 1. Then we multiply it by 2. From the Z table of cumulative probabilities, one can find that probability G less than 1.19 is 0.8830. Hence, the p-value is, we have to put this 0.8830 here. So, we subtract this from 1 and then we multiply it by 2. Then we get p-value equals to 0.234. Now we have to draw conclusion based on the p-value. The significance level is alpha 0.05. The p-value we have calculated 0.234. So what is the decision rule? For the critical value approach, we have a different rule. For p-value method, we have a different rule. So in p-value method, the decision rule is if p-value is less than alpha, then reject H naught. If p-value greater than alpha, then accept H naught. So what we see here, since the p-value 0.234 is greater than the significance level 0.05, hence accept H naught. Here we can see this line is getting executed. So based on both the methods, p-value method and critical value method, we have arrived at same conclusion that accept H naught null hypothesis. Now we have to understand the interpretation of this conclusion. Here, null hypothesis is accepted. The true population proportion of newborn boys is 0.51. The National Service claim is true that 51% of newborns are boys. So you have to pay attention to the last line here. What is the last line saying? Last line saying is based on the sample provided. This is very important line. Based on the sample provided, the percentage of newborn boy babies do not differ from 51% at a 5% level of significance. Right? So the National Service claim is true, but writing the interpretation, you need to write these two lines based on the sample provided. Why we are using it here? Because whatever the sample is provided to you, you are drawing the conclusion based on that. The man went to a hospital and the hospital provided that data that out of 833 newborns, 433 were boys. Now suppose someone goes to another hospital. Now the hospital will provide the different data. So you will have a different sample. So whatever conclusion you have drawn is based on the sample provided, right? And the last line saying as at a 5% level of significance. So you have to mention at what percent significance level you have drawn this conclusion. Because many times we have 1% significance level, many times we have 10% level of significance. So you have to mention both these lines. What is that? Based on the sample provided or based on the data provided. And second is what at what percent level of significance you have conducted this test, right? So thank you very much for watching this video. Please like and subscribe the channel. Meet you in the next video. Thank you very much.